Lesson 4.3, found on page 161, is titled Equivalent Ratios and Multiplication Tables. So here we have a multiplication table, and we're going to figure out equivalent ratios using these tables. The essential question: how can you use a multiplication table to find equivalent ratios? The table below shows two rows from the multiplication table. This table here is two rows. For row 1 and for row 6, and they made those blue here to emphasize them. The ratios shown in each column of the table are equivalent to the original ratio. So 1 to 6 is our original ratio. 2 to 12 is also an equivalent ratio, and so on. Ratios that name the same comparison are equivalent ratios. All right, so as you saw before, 1 to 6 is our original, our unit rate, our original ratio. So for every bag, the farmer's putting 6 apples in it. So if you bought 2 bags, you'd end up with 12 apples, right? So this ratio right here, the 1 to 6, is the same as 2 to 12. You just bought more bags, so you ended up with more apples. So if I bought 3 bags, I'd have 13 apples. If I bought 4 bags, I'd end up with 24 apples. If I bought 5 bags, I'd end up with 30 apples. All right, so we can use these tables to figure out equivalent ratios. Unlock the problem. Here we go. The ratio of adults to students on a field trip is 3 to 8. So for every adult, there are 8 children, students. Write two ratios that are equivalent to 3 adults to 8 children. So if we had 16 children, we would need 6 adults. If we had 24 children, we would need 9 adults. If we had 32 children on our field trip, we would need 12 chaperoning adults. All right, so use the multiplication table. Shade the rows that show the original ratio, which they did for us, the 3 to 8. That's the original ratio. They shaded it in blue for us. The original ratio then was 3 adults to 8 students. So shade the row for 3 and for 8. Again, they did that for us. Blue and blue. Then we circle the column that shows the original ratio. They did that for us again. There is one, let's see. All right, there is one group of 3 adults for every group of 8 students. They did the first one for us and the second one. I did the third one and the fourth one. Circle 2 columns that show equivalent ratios. The column for 2 shows there are 2 times 3 or 6 adults. Whoop. When there are 2 times 8 or 16 students. Okay, so the next row shows us in this third column, when we have 3 groups of adults, then there's 9 total. 3 times 3 3 times 3 is 9. When there are 3 times 8 students, or 24 students. So we know that 6 and 16, 6/16 is an equivalent ratio. 6/16 is an equivalent ratio, and so is 9/24 to 3/8. 6/16 is equivalent, 9/24 is equivalent, 12/32 is equivalent, and so on. All the way across, all of these are equivalent ratios to the original. All right, let's do it again. Here we go again. Jessa made fruit punch by mixing 2 pints of orange juice with 5 pints of pineapple juice. To make more punch, because she's inviting more people, she needs to mix orange juice and pineapple juice in the same ratio, right? 3 equivalent ratios for 2 to 5. Use the rows from the multiplication table to help you complete the table of equivalent ratios. So, first of all, 2 to 5 is our original ratio here in our multiplication table. Okay, so we're going to circle that so we remember which one was the original. Okay, 2 to 5. That means 4 to 10 is also an equivalent ratio. So is 6 to 15, 8 to 20, and 10 to 25. Those are all equivalent ratios. So if she needed to have a big party, instead of going with her original recipe, which was 2 orange juice to 5 pineapple, she's going to invite, 100 people to her party. So she needs 10 orange juice pints for 25 pineapple juice pints, so everybody can have a drink at the party, okay? So they can enjoy her punch. All right, so what they did here is they just yanked these 2 blue rows out and put them over here. Notice it starts with 2, this one starts with 2, and this is our orange juice. Here's our pineapple, starts with 5 over here, 5 over here. So they just transferred these over and made them a table. Now this is a little more familiar to us. All right, so our original ratio was 2 to 5. So if we need to double our ratio or multiply it by 2, we end up with 4. 2 times 2 is 4. And this down here is 2 times 5, which is 10. Or if we need to triple the ratio, make 3 times the amount of the original, we'd end up with 6 orange juice pints and 3 times 5, which is 15 pineapple. 6 to 15, 6 to 15. If we needed to make 4 times as much, that's a lot. And notice we're just counting by ones. This is, let's say this is 1 times 2, and this is 1 times 5. That's our original ratio. Then we've got 2 times 2, 3 times 2, 4 times 2. We're just counting up by 1 each time as we work our way up the table. 1 times 5, 2 times 5, 3 times 5, 4 times 5 as we work our way up. Make that look like times 5 instead of 0.5. All right, 4 times 5 is 20, so 8 orange juice to 20 pineapple. All right, so here are some equivalent ratios that we can write down. We have, if 2 to 5 was our original, so 4 to 10 6 to 15, 8 to 20 are all equivalent ratios. In other words, she's going to get the same tasting punch. If she wants it to taste the same but make a whole lot of it, she has to use an equivalent ratio in order to do that. We use equivalent ratios in cooking all the time. Another way, multiply or divide by a form of 1. Remember, okay, 1, if you multiply anything times 1, it doesn't affect the outcome, does it? 2 times 1 is 2, 3 times 1 is 3, 4 times 1 is 4. It really doesn't change the outcome. So, let's put in here, let's put 2 over 2. 2 divided by 2 is still 1, isn't it? So it really hasn't changed the outcome. So that's what they're saying when they say a form of 1, which is a fraction that is the numerator and the denominator is the same. That's a form of 1. That's what they're talking about right there, where the numerator and the denominator are the same. That's how we get our equivalent ratios. All right, so multiply by a form of 1. Multiply the numerator and the denominator by the same number. So let's pick an easy number. We can pick 2, we can pick 3. I wouldn't pick 15. That's just a big, awkward number. I'd rather choose something that's easy. So let's multiply by 2 over 2 because that's a form of 1. 6 times 2 is 12. 8 times 2 is 16. So 6 over 8 is an equivalent ratio of 12 over 16. They're equivalent ratios. If I'd set this up in a table, it would work just the same. It's just tables are a little more familiar. The first ratio would be 6 over 8, and then I would put times 2 for the second part of my table. I'd end up with 12 over 16. This one would be times 3. I would end up with 6 times 3 is 18, 6, 24. 3 times 8 is 24. This one would be times 4. 4 times 6 is 24. 4 times 8 is 32. All of those would have worked. This is the exact same thing as setting up a table. See how my outcome is the same as the table, the times 2 table. So watch this if I do this again. 6 over 8 times 3 over 3. I end up with 18 over 24. Look at that. It's the same thing as what's going on in the table. We're doing the exact same thing. We're just not bothering to draw a table. That's it. That's the only difference. Okay, it works the same way with division. Divide the numerator and the denominator by the same number, or a form of 1. So it has to be the same on the top and on the bottom. In this case, I'm going to use 2 again just because it's easy. 6 divided by 2 is 3. 8 divided by 2 is 4. So, knowing this outcome up here, 3/4 equals 6/8 equals 12/16. They're all equivalent fractions. All right, so finally, explain how ratios are similar to fractions and explain how they're different. Ratios and fractions make comparisons by division. Ratios and fractions, because those ratios look like fractions, don't they? They make comparisons by division. They're both written with a numerator and a denominator. That's a numerator, that's a denominator. And the difference, though, is that ratios can also be written with the word to or a colon. And we don't do that with fractions. So that's where they're different. All right, do the rest with your class. Let's take a look at our notes. All right, so for our notes today, there's a couple different ways that we can figure out equivalent ratios. We can use a multiplication table and shade the rows representing the numerator, then the row representing the denominator. Then we choose a column, and where the column crosses the shaded row, there's an equivalent fraction. So if I choose, let's say 2, here they did one for you, but I'm going to show you another one. Let's say I chose 2 and let's say 7. Every column now that crosses those two is an equivalent fraction. So 2 to 7 is the same as 4 to 14, is the same as 6 to 21, 8 to 28. Okay, basically it's just a table, equivalent ratios table in a multiplication table. All right, but kind of the more mathematically mature way is to divide or multiply by a form of 1. So when we divide or multiply by a form of 1, let's say we started with 3/4, we multiplied by 2 over 2, which is a form of 1, we get 6 over 8. Or 10 over 10, we get 30 over 40. This is still a form of 1, so 3/4, 6/8, and 30 over 40 are all equivalent. And then the other way that they showed us was just make a table. If this is what you're familiar with, that's fine. Draw a whole table. Just make sure you do the times at the top so you remember that you're multiplying everything. So if I started with 4 and 5, I have to multiply both the 4 and the 5 by 2. I get 8 over 10. Multiply them both by 3, I get 12 over 15, and so on. All the ratios in the table are equivalent.